Now we end this topic, complex numbers topic, by solving some of the problems, applications of De Moivre's theorem and nth roots of unity. The number of complex numbers. See, this problem is an application of De Moivre's theorem as well as trigonometric equations. The number of complex numbers, Z satisfying modulus of Z by Z bar plus Z bar by Z is equal to 1, mod Z is equal to 1 and 0 less than arg Z less than 2 pi is 1, 2, 2, 4, 3, 6 and 4, 8. Now solution is, let Z be is equal to cos theta plus I sin theta, so that Z bar is equal to cos theta minus I sin theta. So therefore Z by Z bar plus Z bar by Z is equal to, or I will write modulus of this 1 is equal to, and this is modulus of 2 cos theta, and 2 cos theta implies cos theta is equal to plus or minus 1 by 2. Cos theta is equal to plus or minus 1 by 2. So this shows that 2 theta is equal to how? 2 theta is equal to pi by 3 and 3 pi by 3, 5 pi by 3 and 7 pi by 3 and 11 pi by 3, because you know that cos theta is same as cos 2 pi plus theta and cos 2 pi minus theta. So that's why this is, or theta is equal to pi by 6 and 5 pi by 6, 7 pi by 6 and 11 pi by 6, and all these 4 values, they belong to this interval. They belong to the interval 0, 2 pi. All these values belong to the interval 0, 2 pi. So this is 4 in number, and cos 2 theta is equal to minus of, now cos 2 theta is equal to minus of implies 2 theta is equal to 2 pi by 3 and 4 pi by 3 and 8 pi by 3 and 10 pi by 3, or theta is equal to pi by 3, 2 pi by 3, 4 pi by 3 and 5 pi by 3. So 5 pi by 3 means what you get is, so 5 pi by 3, how do you get? 2 pi minus pi by 3. That means 2 theta value, that is. So therefore how many? This 4 and this 4. So total number of values theta belonging to 0 to pi is 8. So the correct option is option number 4. The common roots, of course this is once asked in EAMCET examination. The common roots of the equations x power 12 minus 1 equal to 0 and x power 4 plus x square plus 1 equal to 0, or 1 omega square 2 minus omega square, 3 plus or minus omega square, 4 plus or minus omega square, comma plus or minus omega power 5, where omega not equal to 1 is a cube root of unity. This is once asked in, of course, I don't remember exactly the year, but it is asked in a EAMCET examination. X power 12 minus 1 can be written as x power plus 1, x power 6 plus 1 into x power 6 minus 1. So this can be written as x power 6 plus 1 into x square minus 1 into x power 4 plus x square plus 1 equal to 0. So x power 4 plus x square plus 1 is a factor of x power 12 minus 1. So therefore x power 4 plus x square plus 1 is a factor of x power 12 minus 1, and hence the roots of x power 4 plus x square plus 1 equal to 0 are the common roots, So now x power 4 plus x square plus 1 equal to 0 implies x square is equal to minus 1 plus or minus I root 3 by 2, and these are nothing but omega and omega square. Omega and omega square. So x square is equal to omega implies x is equal to plus or minus square root of omega, which is plus or minus square root of omega means 1 by omega square. So that is plus or minus 1 by omega. Again 1 by omega means omega square. 1 by omega means omega square. Similarly, x square is equal to minus omega implies x is equal to plus or minus omega. Similarly. So therefore, the roots are common roots. Plus or minus omega, plus or minus omega square. So option number 3. And you can also work this problem, because this you can again factorize it. X square this again. See, also x power 4 plus x square plus 1 equal to 0 can be written as is x power 4 plus 1 whole square minus x square, and this is equal to 0 means x square plus x plus 1 equal to into x square minus x plus 1 equal to 0. So from this also you can get. So from this also we can get x values. Same values you will get plus or minus omega square. You can remember one factor. The common roots of two polynomial equations. To get what you have to do is you have to find the GCD, greatest common divisor of the both polynomials, and then the roots of that GCD will be the common roots always. Xk is equal to cos 3 pi cos pi by 3 power k plus I sin pi by 3 power k. Then limit of n tends to infinity, x1 into x2 into x3, etc. xn, x1 into x2 into x3 into xn is equal to 1, 0, sorry, 1, 1, 2, minus 1, 3, I, and 4, minus I. Minus I. So, solution is just application of De Mor's theorem. This is x1 into x2 into x3, etc. xn is equal to, I will write cis pi by 3 into cis pi by 3 square into cis pi by 3 cube, etc. cis pi by 3 power n, where cis theta means I sin theta. And you know it's a fundamental property of when you multiply two exponents of this type, that means cos alpha plus I sin alpha into cos beta plus I sin beta, then the angles will be added, cos alpha plus beta plus I sin alpha plus beta. So therefore, this is equal to cis of pi by 3 plus pi by 3 square plus pi by 3 cubed, etc. pi by 3 power n. So that is cis of, if you take pi by 3 outside, cis pi by 3 into 1 plus 1 by 3 plus 1 by 3 square, etc. up to 1 by 3 power n minus 1, which is geometric progression. So that is cis pi by 3 into 1 minus 1 by 3 power n by 1 minus 1 by 3. So which is nothing but cis pi by 3 into, of course, then, or you can write cis pi by 3 into this 3 goes to the numerator. So 1 by, we take just. So therefore limit, you can take directly, limit x1, x2, etc. xn n tends to infinity is cos cis pi by 3 into 1 by 1 minus 1 by 3, 1 by 1 minus 1 by 3, which is cis pi by 2. This 3 simplify, if you simplify it, this is 3 by 2, 3 will cancel, pi by 2. But cis pi by 2 means, that is cos pi by 2 plus I sin pi by 2, which is nothing but I. Which is nothing but I itself. Answer kenda idu padutunda? Right. So answer is 3. Option number 3. If problem, if 1 plus x whole power n is equal to p0 plus p1x plus p2x square plus etc. pn x power n, then p0 minus p2 plus p4 minus p6 plus etc. is equal to 1, 2 power n by 2 into cos n pi by 4, 2 power n minus 2 by 2 into cos n pi by 4. 3. 2 power n by 2 into sin n pi by 4. And 4. 2 power n minus 2 by 2 into sin n pi by 4. In the given expansion, put x is equal to I, both sides. So therefore, you will have 1 plus I whole power n is equal to P naught plus P1I minus P2 plus minus P3I plus P4 and plus P5I, etc. Because since I square is equal to minus 1, I cubed is equal to minus I to the power of 4 is equal to plus 1, I to the power of 5 is equal to I, etc. So that is P naught minus P2 plus P4, etc. separating real and imaginary parts, plus I into P1 minus P3 plus P5 minus P7, etc. But 1 plus I whole power n is root 2 into cos pi by 4 plus I sin pi by 4, this whole to the power of n. So by De Morgan's theorem, this is 2 power n by 2 into cos n pi by 4 plus I sin n pi by 4. So this is equal to this. So equating real parts. So equating real parts, we have P naught minus P2 plus P4 minus P6, etc. is equal to 2 power n by 2 into cos n pi by 4. Cos n pi by 4. And P1 minus P3 plus P5 minus P7 is 2 power n by 2 into sin n pi by 4. Sin n pi by 4. So because this number is equal to this, two complex numbers are equal if and only if the real parts are equal, imaginary parts are equal. So this is 2 power n by 2 into cos n pi by 4. So the real part is equal to 2 power n by 2 cos n pi by 4. And the imaginary part is equal to 2 power n by 2 into sin n pi by 4. That means if more than one question, one answer questions, you can ask, this is also correct answer. More than one question, so this is also correct answer. If alpha is a non-real sixth root of unity, non-real sixth root of unity, then alpha power 5 plus alpha cubed plus alpha plus 1 by alpha square plus 1 is equal to 1, 0, 2 alpha, 3 alpha square and 4 minus alpha square. This is. So you know that, and solution is alpha power 6 minus 1 is simply alpha minus alpha, I'll write alpha square whole cubed minus 1. Okay, so this we can write as alpha square plus 1, alpha square plus 1 into what you get is, for this alpha is equal to plus 1 and minus 1 are also roots. So now you can write it as alpha 6 minus 1 equal to 0 means alpha power 6 is equal to 1. Okay. Now alpha power 5, alpha cubed plus alpha plus 1 by alpha square plus 1 can be written as alpha power 5 plus alpha power 4 plus alpha cubed plus alpha plus 1. That means you have added alpha square and we have alpha power 4 and alpha square. So subtract it. Minus of alpha power 4 plus alpha square. This whole by alpha square plus 1. So what we did is simply in the numerator add and subtract alpha power 4 plus alpha square. Then you will get it this one. But you know that this is sum of the 6 roots of unity. 0 minus of alpha power 4 alpha square by alpha square plus 1. Since sum of nth roots of unity is equal to 0. Here n is 6. So that is simply minus alpha square. If you take alpha square outside, alpha square plus 1, alpha square plus 1 will cancel. So which is equal to minus alpha square. So option number 4. If alpha is a fourth root of unity, is problem. Alpha is the fourth root of unity. Not alpha. And suppose, just wait, instead of y lengthy, I will shortcut it in the problem. If Z1, Z2, Z3 and Z4 are fourth roots of unity,